Today we get to look inside something a little bit different. This is a 6 kilovolt impulse tester. What does it do? Well, it simulates lightning strikes or grid events that generate transients on the mains power system. And this tests devices to ensure that they can withstand what is considered a normal events on the mains power supply. So this would be used to test equipment such as telephone equipment that is hooked up to the telephone network. These days it would be used to test solar powered systems to make sure that those systems are able to withstand normal transients coming down the mains, and any other equipment that you would expect to connect to the main system. I'm opening this unit up today to do a safety inspection. My aim is to make sure that it is safe to connect to the mains, and that was also an opportunity to take a look and see what's inside. So let's get to it. I don't have any documentation at all on this impulse tester, but I think it's relatively easy to figure out what the controls do on the front panel. There's a power switch down there, but it's pretty obvious what that does. There's a high voltage and low voltage indicator lamps there, so I suspect that they indicate whether there is high voltage present on the outputs or if it's safe to connect in to the outputs. There's a manual auto trigger there, and you can manually trigger impulses. There's a voltage control here which goes from 0 to 100, and 100% in this case would be 6 kilovolts. There is surges per minute, so it would appear to me that you can set this up to do, say, anything between 1 and 6 surges per minute. Set it on auto and it'll just keep sending out pulses until you switch it back to manual. And there's a polarity here, so there's an opportunity there to switch to a negative pulse, a positive negative pulse, or a positive only pulse. There's a reset flash indicator lamp there, so I'd say that if there is a flashover on the device under test, that is the reset for it. And there is a reset peak voltmeter. So the voltmeter here is probably going to record the peak value of the impulse voltage, and that allows you to reset that. There appears to be a surge counter preset. There's damping resistors here, so this will be set up to switch in and out various resistors to change the characteristics of the impulse that you're sending down to the device under test. And there is a impulse shape switch here which switches in and out various capacitors and resistors. And so the front panel controls are reasonably straightforward, but without any documentation, any operations manual. I'm taking an educated guess. I'm not actually relying on what the manufacturer has said. Well, if we take a look at what's inside, what's under the covers, the thing that dominates the whole of the enclosure is this device here, and this is a 20 microfarad 6 kilovolt capacitor. I know from previous experience this is oil filled, so what I'm looking for here is if there are any leaks around the glands, and I can't see any, which is a really good sign. The enclosure is fully welded along all the seams, so unless there's a flaw in the weld, there shouldn't be any oil leakage anywhere. So that's checked out. That connects into a high voltage switch, which is this device here. So this shaft here, which is connected down through an insulator to that motor drive down there, that rotates to switch from one side to the other. And so you can actually see right in there are points, burn marks, where this switch has flicked across and has been an arc, and it is broken and made a connection. The switching here throughout this device selects different combinations of resistors, and then we have these orange devices down here which are capacitors, high voltage capacitors obviously, And across here we've got more capacitors, and they have an insulator on the top of a can. There's switches in the other parts which also have the similar sort of arrangement where you've got a shaft, an insulated shaft driven by a motor down there, and then you've got this arm which swings across from one bolt head to another, and that's how it switches 6 kilovolts. Over this side we've got yet another switching arrangement down here. This is different. What we've got here is a series of springs, and these make an electrical connection between 2 points all the way down the shaft. And then it's a bit difficult to see, but there are some springs here which are just sticking out, and there is it's not focusing. Let's try again. Alright, it's really difficult to see, but down there's these springs which are just sticking out, and they just have a sharp point out on the end. And when this shaft rotates, it rotates around to touch these springs onto these bolt heads, and that's it. That is another 6 kilovolt switch. On the front here we've got these high voltage switches. We've got these ceramic carriers, and if you look down there you'll see that there are wafers sticking out, and as the switch is rotated, the switch makes contact or breaks contact with those wafers. And a similar arrangement for the second bank here. Perhaps a little easier to see here where we've got just one bank, and you can see the switch wafers going around from switching point to switching point. Very solid motion to this. Down the bottom is the control circuitry, and what's notable about this is that there are no wet components down there. There's no electrolytic capacitors or tantalum capacitors that I can see that would degrade over time. Very simple circuitry, but as you'd expect with 6 kilovolts, you don't want anything that's complicated and delicate. And the rear panel just has the outputs here. There's another output down there. Earthing point, really important on this high voltage stuff. This earthing point is really solid. It's designed to have a separate earthing arrangement, and not through the mains earthing. There's a connector here for a remote triggering, so you can stand away from this whole thing, and there's a fuse at that point there. So there's quite a lot in here, but it's also reasonably basic in terms of its electrical design, but I would say there's a lot of design work gone into making sure that this can do what it does. Right, so I've given the impulse tester a thorough inspection, and I can't see any defects in here. There's no oil leaking anywhere, there's no loose connections that I can see, there's nothing cracked, there's no evidence that this system has been dropped, which would have caused a bit of trauma inside. Everything looks fine to me, and I'd be happy to apply power to this. But I'm not going to do that because I don't have an earthing system to plug this into.